This is number 6 on Unit 5, Lesson 4, Practice Problems. In this lesson, we learned that when you take the area of your original figure, you multiply it by k squared, right, the scale factor to the second power, and that gives you the area of your scaled or your new figure. This question is asking you to take that concept and apply it to circles. So it starts out by saying that if we have a circle that has a radius of 1, so here's my circle, the radius is 1 unit. All right, so for my original circle, right, the radius was 1 unit. We know that if we want to find the area of a circle, the formula that we learned is area equals pi times the radius squared, right? So just using that formula, I would take the radius of 1 and plug it into my formula. Area equals pi times 1 squared. Well, 1 squared is 1. Pi times 1 is just pi. So the area of this circle is what we say is pi units squared, right? Or pi square units. Okay, so that was all given to you in the problem. When we have a radius of 1, the area is pi square units. Now, if this is our original figure, right, we also say that the scale factor was 1. K was 1, right? Because that's our original area. That's our original figure. That's our starting figure. Ooh, I had a kitty walking on my keyboard. Okay, so now if we take, let's say we want to scale it, right? If this is my original figure, what if now I want there to be a scale factor of 2 instead? Well, if I take my radius and I multiply it by 2, now my new radius is 2 units long. 2 units, 2 units, 2 units. Here's my new circle. Okay, so this circle has a radius of 2, had a scale factor of 2, and if we use the pattern that we used with our rectangles in this lesson, we could take the original area of pi and we can multiply it by k squared. So since k is 2, we're going to do pi times k squared, 2 squared. Well, 2 squared is 4, right? So we would say the area for this figure is 4 pi. 4 pi units squared, I guess I should say. Okay, so to get the area on this one, the process that we used was our original area of pi times k squared, right? Well, what if we did the area formula for a circle, pi times the radius squared? Well, for this problem, the radius was 2, right? So if I plug in a 2 for the radius, now I have pi times 2 squared, or 4 times pi. And 4 pi square units is the same thing that we got from using our scale factor squared. Okay, so then what if we want to scale again, and this time we want maybe a scale factor of 3 from the original one. So now if our scale factor is 3, I know that my radius is going to be 3 because my original radius was 1. 1 times 3 gives me 3 for my new radius. Okay, 3. So if I have a radius of 3, here's my circle. Yeah, I'm not so good at circles here. Okay, so we said the scale factor for this one was 3. That made our radius 3. And so if we use our pattern from this lesson, we would do our scale factor times, or our scale factor squared times our original area, right? So the original area of our very first figure was pi times k squared. K was 3, so that's pi times 3 squared. Well, 3 squared is 9, so the area is 9 pi square units. And again, if we compare that to the area formula, right, area equals pi times the radius squared. Well, the radius was 3. If I plug that in, I have the exact same problem again. 3 squared times pi is going to give me 9 pi square units for my area. So when I'm looking at the method that I'm using with my scale factor, and then I'm looking at the method that I'm using with my area formula, hopefully we're kind of seeing that there's only one piece that's different there, and it's whether we're using the variable k or whether we're using the variable r. Well, we're getting the exact same result every time because k and r are the exact same number every time. When I look at scaling a circle, changing that scale factor changes our radius by the exact same amount. So when it comes to circles, our scale factor will always equal the radius of our circle. Okay, and that's kind of what this problem is asking you about. It's asking you to give me an explanation of why this works, right? Why is it that I'm getting the exact same thing whether I use pi times k squared or whether I use pi times r squared? Well, it's because the radius is functioning as your scale factor. Your scale factor is directly impacting your radius. They're always going to be the exact same number every time. So if I wanted to maybe do a circle that had a radius of 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. All right, so a circle that has a radius of 4. If my radius is 4, I know my scale factor from the original is 4, which means the area, no matter which method I use, is going to be pi times 4 squared. So I'm going to get an area of 16 pi square units. Okay.